Well, let's talk about a few suggestions for setting up a frequency table for a list of numbers, like we did this in the previous video. And this is really a summary of what we did. So, we choose a category or grouping width. So how many numbers do you want in each interval? Last time we did, I believe, well, one time we did 25 in each interval. I think that was the most recent example. And for example, one group from a finite math class could have test scores from 81 to 90. So my finite math class might have scores, let's say, from 60 to 69 for a D, 70 to 79 for a C, 80 to 89 for a B, and then 90 to 100 for an A. Now, are these exactly equal widths? Not quite. 0 to 9 is 10 different numbers. 60 to 69 is 10. 70 to 79 is 10. 80 to 89 is 10. 90 to 99 would be 10. But this includes 100, so there are actually 11 numbers in 90 to 100. And you'll see that sometimes the leftmost or rightmost intervals, or in this case the top or bottom, could slightly deviate from the others. That's not a major deal. But you don't want it to be, significantly smaller than or significantly larger than the other interval widths. So they should be of equal length. Again, the groups on either end might vary slightly, and that's not a big problem. Okay, so what you do with all of the numbers is you rewrite the numbers in their correct categories so you can easily count them. It does make it much easier when you do this, and if you have them written in increasing order or decreasing order, it also helps. So for example, you sort all the finite math test grades from lowest to highest, and then you can easily find the correct groupings like we did in the previous video. And then just count the numbers of numbers, the number of numbers or test scores in each category. This gives you the frequency for each category. And that's what we have in a frequency table. All right, another way that we can have a diagram that shows data. It's called a stem and leaf plot. Truthfully, I have rarely used this, and I have rarely put one on an exam. But we're going to go over it anyways. You might have a homework problem or two. Stem and leaf plots are primarily used to summarize lists of numbers that have 2 or 3 digits. The stem and leaf plot is similar to a frequency table, only for 2-digit numbers. The first digit is the stem, and the second digit is the leaf. The stem is used as the category for the grouped data, and you'll see what we mean right here. So the stems are going to be like the tens place. So this would be a 2. This would have a stem of a 2. This stem would be a 1. This would be a 1. This one would be a 2. All right, so our numbers seem to range from single digits 7 up through 48, I think. Okay, so for our stems, and let's make a note that we have 2 single-digit numbers. Let's call 7 a 0, 7 and call 9 a 0, 9. So now we can use that 0 as a stem, and the leaves would be 7 and 9. We have a 0, 7 and a 0, 9, and I'm going to mark them out each time I write them down so that make sure I get all of them. Now let's go to the stem of 1, which means we're in the teens. So I've got a 13 and a 17, which means I'm going to put a 3 and a 7. And here's a 15, which means I'm going to put a 5 here. Remember, we're just writing the ones place under here as the leaves. And then we have a 10, so it's ones, that'd be a 0. And that's it for the tens. Now let's go to the 20s. We have a 2, 1. A 2, 4, which means I put a 4 here. And another 4. So 24 showed up twice. That's fine. All right, now we go to 3. 3 means we have a 31 and a 39, which means I'll have a 1 and a 9. And we have a 33, which means I'll put a 3 there. And now we go to 4. This should be the final one. And I'll have a 48 and a 46, which means I'll put the 8 and a 6 there. And a 44 means 44. And a 41. And another 46. So it's perfectly fine to have 2 6s here. So if all I knew, if I didn't know any of these numbers here, but I were given this chart, I could easily reproduce them. 0, 7, 0, 9, that means 7 or 9. When the stem is a 1, that's a tens place, 1 in the tens place. That would give me a 13, a 17, a 15, and a 10. And let's just jump down to the bottom one. 4, it means we're 40-something. 48, 46, 44, 41, 46. And then it would be simple then to extend this to a frequency. I'd mentioned the frequency table, where all you need to do is count the leaves. So we have a frequency of 2, 4, 1, 2, 3, 3, 1, 2, 3, 3, 2, 3, 4, 5. So that's our frequency. And actually, we're going to use these numbers in number 7 when we talk about a histogram. A histogram is just a bar chart. I'm sure whether you know it as the name histogram or not, I'm sure you've seen them before. Okay, the height of the histogram, kind of a bar, for a particular category represents the frequency of that category. The larger or taller the bar is, the greater the frequency is. For an example, let's make a histogram using the data from the previous problem. That means from our stem and leaf plot above. So naturally we'll choose, naturally because we chose the tens place to be the stem, and this is the ones places, we are going to use intervals of width 10, namely 0 to 9, 10 to 19, and so on. We're going to have 1, 2, 3, 4, 5 intervals covering from 0 through 49. All right? Because our biggest number was a 48 and our smallest number was a 7. So here's how we make a histogram. Not a very straight line there, unfortunately. And we're going to break it up into kind of like the x-axis, if you want to think of it that way, the horizontal line. I need 1, 2, 3, 4, 5 categories. So 1, 2, 3, 4, 5. I'm going to have 5 bars, actually. Okay, so all I need to plot, the bars, these basically represent, these frequencies, the height of the bar. So the smallest one is going to be a height of 2, and the top one will be a height of 5. So let's just do evenly from 1, 2, 3, 4, 5. Those are going to be our heights. We don't have any of height 1, but that's fine. Okay, so the first one, we're going to label this down here, the categories. We're going to do 0 to 9 here, 10 to 19 here, 20 to 29 here, then 30 to 39, and finally 40 to 49. So notice from 0 to 9 we have a frequency of 2. Remember, it was just the numbers 7 and 9. So we're going to just draw a bar that has a height of 2. Just like that. 10 to 19 means the stem was a 1. We had a frequency of 4. So the height would be, we go up like this, and then a height of 4, like so. And then 20 to 29 should be a height of 3. I actually notice that the next one, 30 to 39, is also a height of 3. So 3 is about right here. I'm going to go all the way across, 2 intervals. And then go ahead and separate them right there. And the last one has a height of 5. That's the tallest one. So a height of 5. So we'll go up like this. So this very nicely summarizes the data. You can see that more people scored between 40 and 49 than any other range because this is the tallest bar among them. And the shortest one looks like it's here. So the smallest one would be from 0 to 9.